All right, last part of this lab here, all about interpolation. If we hop back to the lab document, interpolation is the inference of values between measurements. So if you have a value of 10 at one point and a value of 20 at another point, we might interpolate the point exactly in between, exactly halfway between those points, 10 and 20. We might infer that that point is valued at 15. Well, it's a lot more complicated as we get over different conceptions of space, more data, more points. Interpolation tools help us do that. For funsies, let's bring that elevation data back that we did extract values to points on. Why? Because it's fun. That's why. If I can remember where I put that data, there it is. It's in my default geodatabase. Don't be like me. Don't be like me. So here's all of that data. Again, if I look at the attribute table, I have my raster value here. We remember that that raster value is a extract values to points of elevation. So what if we tried to reconstruct that topography raster just from the points that we have here? Maybe we lost the elevation file. Maybe we're just really into landscape modeling and we want to see how good it looks. Maybe we're just going a little crazy. Let's interpolate. There are a number of different interpolation methods, algorithms, ways to do it. And I will actually bring up the toolbox here, just because. Oh, look at all those toolboxes. There's so many exciting toolboxes. Might as well just look at the lab for where these are. Spatial analyst, interpolation. Great. So here's all of our different interpolations. Tough to find, tough to see what's going on. We're just going to start with the most simple one, inverse distance weighting. Inverse distance weighting basically says the further you get away from the value, the less likely you are to be like that value. It's Tobler's first law of geography, just in mathematic form. So let's try to recreate that topography raster that we were working with earlier. So I'm going to take my point features, and I'm going to use the raster value here. So again, what I'm saying is that I have these elevation data, this elevation information on the shape file. I want to try to recreate the underlying topography. I'm going to remember that IDW from extract, that's a good name. I'm going to remember that my cell size of that original raster was 30 meters. So I'm going to put 30 back in. Because I want to try to replicate that. I don't want to mess around with scale here. So I'm going to try to replicate the original topography raster at 30 meter scale. I have no qualms with those defaults. So I'm going to hit run. Now it seems a little silly because we have the topography raster, right? But if you're doing surveys, if you're trying to collect information about some other characteristic that is steady over a landscape, you might do this. Precipitation data does this all the time. We do not have weather stations evenly spaced every meter or every 10 meters or every 100 meters even to be able to collect pure surfaces of rainfall or snowfall data. Yet, when we get a big rainstorm or when we get a big snowfall, you see that beautiful blanket of here's 3 to 5 inches, here's 5 to 7 inches, so on and so forth. That's all interpolated. They take the official readings, they take the hobby weather station readings, and they put all of those together to make something that looks like this. Here's our interpolated elevation raster. It kind of works. Now, we have a data coverage issue. We do not have data throughout this entire view, so we get a little bit of bullseye. That's something that IDW is very particular about. It makes bullseyes a lot. Makes sense. The further you get from something, the less like that something you are. But when we have very dense data like we do in the middle here, it actually looks pretty good. If we were to insert that old or the original, the correct, we might say, data here. Let's go there and let's go. Oh, I can hardly see with all this weirdness that you're doing here. 7, where are you? There you go. Data Lab 7, topography. If we were to insert that, kind of flip between these, it'd probably be helpful if I could see these on the same color ramp. Let's see, which one did I go with here? The pink, is that pink and white at the top? Yeah, that looks about right. It's not the worst. It captures the valleys pretty well, the basins of the basin and range out here. Certainly not the same resolution, of course. We don't have nearly as many data points, as many clear data points. Another thing you might be noticing is that the original topography raster is bigger. That's because IDW cannot assume outside of the boundaries of its data. Very dangerous. We don't do that. I think it looks all right. Play around with those other interpolation methods. If you're brave, try a Kriging. When you're done having a bunch of fun with that, come on down to the lab production. I'll be at this video link. Give you some tips on that.